Next, we need to know programming. Yes, quadratic programming. Wolf simplex method, Beal's method, and KT conditions. So Kuhn-Tucker conditions. So these are the three important topics. KT conditions, Wolf method, Wolf modified method, or modified simplex method. Next, Beal's method. So these two are it. Wolf method, Beal's method. General quadratic programming problem. D is equals summation j is equals to 1 to n cj xj plus 1 by 2 summation j is equals to 1 to n summation k is equals to 1 to n djk dj xk. So this is objective function. So this is objective function. Next, subject to constants. Subject to constants, summation j is equals to 1 to n aij xj less than or is equals to bj. I is equals to 1 to m. So these are the objective function. These are subject to constants. So in simple, this is so z is equals to c into x plus 1 by 2 x power t q into x. So this is objective function subject to constants ax less than or is equals to b and non-negative restrictions x greater than or is equals to 0. So c is equals to c1, c2 up to cn and x is equals to x1, x2 up to xn transpose. B is equals to b1, b2, bm transpose. So these are the quadratic programming problem. General quadratic programming problem. Next, KT conditions. Conditions. So these are important conditions. These are the five conditions. So these are the conditions. First one, second, third, five conditions are there. So the KT conditions. First one, Cj plus summation I is equals to 1 to n d j djk into xk minus summation I is equals to 1 to m aij lambda j plus mu j is equals to 0. So j is equals to 1 to n. So this is the first condition. So next, second one, lambda I s1 square is equals to 0, I is equals to 1 to n. So this is the second condition. So next, third one, minus 2 mu j r j is equals to 0. So this is the third one. So fourth condition, summation j is equals to 1 to n aij xj less than or is equals to bi that is equals to 0. And fifth one, sum minus j plus rj square is equals to 0. So that implies xj greater than or is equals to 0. So these are the five conditions, KT conditions, Kuhn-Tucker conditions. Okay, 4 marks question. This is important for 4 marks. Write down KT conditions. So we can write these five conditions. Next. So this is method, Wolf modified complex method. Maximum of z is equals to f of x1, x2 up to xn. So that implies summation x, summation j is equals to 1 to n cj xj plus 1 by 2 summation j is equals to 1 to n summation dik into xj into xk. So these are the constants. Summation aij xj less than or is equals to bi. So these are subject to constants. This is quadratic programming problem. Previous one. Quadratic programming problem. Subject to constants. So these are the steps. First, convert the inequality constants into equality constants by involving slack variables. In the ith constant and the slack variable, Rj square in the jth non-negative constant. So these are the steps to involving Wolf method. So directly example. So this is very simply example one. The given quadratic problem minimization from convert it into the maximization. Example one, using Wolf method to solve the quadratic QPP, quadratic programming problem. So maximization. So maximization. So question example one. So this. So maximization, maximum of z is equals to 4x1 plus 6x2 minus 2x1 square minus 2x1 x2 minus 2x2 square subjected to constants x1 plus 2x2 less than or is equals to 2. And these are the non-negative constants. So this is the question. Using method to solve the quadratic programming problem. So these are the questions. First, first we have to convert the all constants to inequalities. The first one, first equation, x1 plus 2x2 less than or is equals to 2. So we can add a slog variable. So that is x1 plus 2x2, x1 plus 2x2, s1 square. Here we are adding s1 square. Is given in method adding square variables only s1 square plus r1 square plus r2 square. In constants, we can add only s1 square, s2 square, s3 square. And non-negative constants. These are. So we can add r1 square, r2 square, like this. It's clear? In substituted to constants, so we can add s1 square or subtraction of s1 square and s2 square, like this. And non-negative constants x1 comma x2 greater than or is equals to 0. In this case, we can add r1 square plus r2 square. So r1 square, r2 square, next r3 square, r4 square. So like this. So first equation x1 plus 2x2 less than or is equals to 2. So these are the greater than or is equals to there. So we can multiply both sides by negative. So that is minus x1 less than or is equals to 0, both sides. So next second one, minus x2 less than or is equals to 0. Second equation. So total 3 equations. So this is the first one. So this is the first one. Second equation, minus x1 less than or is equals to like this. This is x. x1 greater than or is equal to 0. First equation, x2 greater than or is equal to 0. Second equation. So next multiply both sides by minus. Minus x1 less than or is equal to 0. Minus x2 less than or is equal to 0. After multiplications, so these are the equations. Now we have to convert inequalities into equalities. So less than or is equals to equality. So here adding slot variable x1 plus 2x2 plus s1 square is equals to 2. Here minus x1 plus r1 square is equals to 0. Minus x2 plus r2 square is equals to 0. And all x1, x2, s1, s2, s3, r1, r2. All are non-negative. That is greater than or is equals to 0. So this is standard form. Is clear? Standard form of given QPP, given quadratic programming problem. So first we have to convert all inequalities into equalities. After we can construct Lagrange's function. So that is L of x1, x2, s1, r1, r2, gamma, lambda, mu. So that is the first equation. First equation is nothing but given objective function. So this is 4x1 plus 6x2 plus minus 3x1 square minus 3x1 x2 minus 3x2 square. So this is the first one. In L of L is equals to, so this is the first one. Next, minus lambda 1. So lambda 1 is nothing but first equation. So this one. So this is the first equation. Lambda 1 into x1 plus 2x2 plus s1 square minus 2. So this is second equation. Next, minus mu into third equation. Minus x1 plus r1 square. Next. So this is mu 2. This is mu 2. Mu 2 into third equation. Mu 2 into minus x2 plus r1 square. So this is the Lagrange's function. So L is equals to the total objective function and subject to constants. So this is the Lagrangian function. L is equals to objective function. So this is first one. Minus. So this is second equation. Minus lambda 1 into. Next. So this is third equation. So this is fourth equation. So minus lambda 1 into second equation x1 plus 2x2 plus s1 square minus 2. Next, minus mu1 into third equation minus mu2 into fourth equation. So this is the Lagrangian function. Next, so differentiate L. So this is the equation 2r1. So this is the equation 1. So next, differentiate equation 1 with respect to all variables, that is x1, x2, r1, r2, mu1, lambda, all equations. So here, so these are the derivatives. So total S1 differentiation, L differentiation x1 with respect to x2, S1 differentiation with respect to R1, R2, all variables, each and every variable. Differentiate L with respect to each and every variable in the Lagrangian function. The first, dou L by dou x1. So differentiation with respect to x1. So remaining x2, remaining all variables are constants. That is differentiation with respect to x1. Remaining variables all are zeros. So dou L by dou x1. So 4 into x1. So differentiation, x1 differentiation 1, so 4. x2 is there. x2 differentiation 0. x2 differentiation 0 minus 4x1. X power n form, n into x power n minus 1, 4x1. Next, here x1 differentiation 1, so minus 2x2. So x2 differentiation total 0. Here minus lambda x1 differentiation 1. Remaining all are zeros. So these are constants. x2 constant, s1 constant, 2 also constant. These are zeros. Next, mu into Next, minus x1 differentiation minus 1 plus mu. Remaining all are zeros. There is no x1 in mu2 into something. So first differentiation 4 minus 4x1 minus 2x2 minus lambda 1 plus mu 1 is equals to 0. So this is the differentiation with respect to x1. So next, differentiation with respect to second variable x2. So dou L1 dou L by dou x2. So x1 there 0, 6 into x2. So that is 6. X1 is there 0. Next, minus 2 x1 x2. X2 differentiation 1 x1. So minus 2 x1. Next, here 4 x2. So that is 4x2. Next, here x2 differentiation 1 minus 2 lambda. So minus 2 lambda 1. So next here, so here with this one plus mu2 is equals to 0. So this is the, so this is mu2. This is mu2. Here also mu2. Printing mistake. Differentiation with respect to x2. Here mu2. Mu2. Here also mu2. So plus mu2 is equals to 0. Differentiation with respect to x2. Next, differentiation with respect to s1. S1 differentiation, these all are constant 0 up to here. Next, here mu2 s2 s1. S1 is nothing but here only 2 s1. So total minus 2 lambda 1 s1 is equals to 0. So this is next. Next variable r1. So differentiation with respect to r1. So these all are zeros. There is no r1. So next, x1 differentiation 0 to r1. So total minus 2 mu1 r1 is equals to 0. So differentiation with respect to r1. So that is 2 mu1 r1 is equals to 0. So similarly r2 also. R2. So remaining all are up to here zeros. So here only r1 is there. X2 differentiation 0. 2 into r2 minus mu1 minus mu2. Mu2 into r2 is equals to 0. So that is differentiation with respect to r2 minus 2 mu2 r2 is equals to 0. So next lambda 1. So next variable lambda 1 is there. So lambda 1 differentiation. So all are zeros. So lambda 1 differentiation 1. Only here only. So this one x1 plus 2x2 minus s1 minus 2 is equals to 0. So that is minus x1 plus 2x2 plus s1 square minus 2 is equals to 0. So next lambda 2. So differentiation with respect to mu1. Mu1 remaining all are zeros. So here only mu1 differentiation 1. So minus of minus x1 plus r1 square is equals to 0. So differentiation with respect to mu2. So this is mu2 here 1 remaining as this. So minus of minus x1 plus r1 is equals to 0. Minus of minus x2 plus r2 is equals to 0. Is clear? First we have to convert inequalities to into equalities. We are getting 3 equations. Next, we can construct a Lagrange's equation. Lagrange's equation consists objective function plus substitute constants and non-negative variables, and differentiate L with respect to each and every variable, that is x1, x2, s1, r1, r2, lambda 1, mu1, mu2. So differentiate with respect to each and every variable. Next, the above equations. The above equations becomes first one minus x1 plus 4x1 plus 2x2 plus lambda, first equation. So above three equations, above all equations. So next, so these two are main equations. Differentiation with respect to x1 and x2. So previous differentiation equations. So these are the subjected to constants for new LPP, linear programming problems. Is clear? Next. So this is differentiation with respect to lambda 1. So these are the three constants for new objective function. Is clear? So introduce non-negative artificial variables. So W1, W2 in the equation 1 and 2 and conditions. So that is, so maximum minimization of ZW. ZW is equals to W1 plus W2. Minimization. So subjected to constants. So subjected to constants is nothing but. So we can add artificial variable here also, here, here. So W1 plus W2 and x1 plus 2x2 plus s1 is equals to 2. So we can add artificial variable for first two variables. So that is differentiation with respect to x1, differentiation with respect to x2. So these are the three equations. So this is objective function. So these are the subjective to constants. So these are the non-negative variables. Mu1 x1 0, mu2 x2 0, these conditions. And lambda 1 s1 is equals to 0. So these are the conditions. So this is clearly LPP. LPP is given QPP, quadratic programming problem. Now we have to convert QPP to LPP, linear programming problem. Next, so linear programming problem into matrix form. So these are the coefficients. First equation, second equation, third equation, and x1, x2, lambda 1, lambda 2, mu1, mu2, w1, w2, s1 square is equals to 4, 6, 2. So this is B matrix. Next, simplex table. So previous method, simplex table, basic variables. So basic variables are W1, W2, S1, W1, W2, S1. So these are the basic variables. XB is equals to this matrix, 4, 6, 2. Next, Cj is equals to coefficients in objective function, 0, x1, 0, x2, 0, x3, 0. All are zeros only. W1, W2 is there. So W1 coefficient 1, W2 coefficient 1. So next, same this matrix on here, copy paste. X1, X2, lambda 1, these are variables. Mu1, mu2, S1, W1, W2. Next, we have to find out minimum ratio. So minimum ratio, first we have to find out delta J. So delta J for each and every variable, that is x1, x2 variable, lambda 1, mu1, mu2, s1, w1, w2 variable. So delta J is equals to Cj xp minus xj. So delta J is equal to Cj xp minus xj. So this is the formula for delta J. So first one, minus 6, minus 6, minus 3. So that is Cb into xp. So CB minus XB minus CJ. So 4 plus 2, 6, 0. So Cj minus Zj. So that is 0 minus 6. So minus 6. Here also. Second variable. So that is CB Xj. So 2, 4, 0. Minus 6. So 0 minus 6. Cj minus Zj. Here formula. Cj minus Zj. So minus 6. Next. Here. CB into delta lambda 1. 1, 2. So that is minus 3. So similarly remaining also, these are the non-negative variables, negative variables, minus 6, minus 6, minus 3. So in this we are taking most negative value. So here minus 6 is there. So we can choose any one. So here choosing x1. X1 is incoming vector. In the above table numerically largest negative value is minus 6 corresponding to x1 x2 columns. That means either these are two variables we can enter it into basic variables. So that is mu1 is equal 0, not in the tables. X1 is considered, so that is x1 is entering variables and replacing, that is, so we can choose x2 as w2 as w1 as outgoing vector. Is clear? Entering variable, outgoing variable. So that is by using minimum ratio. So minimum ratio is xp by xj. So that is first one, xp. So these are the xp variables. So this is entering variable. So 4 by 4, first one, 1. So next, 6 by 2, 3. Next, 3 by 2 by 1. So that is 2. So therefore, 1, 3, 2. So in these three values, so minimum is nothing but 1. So that is W1 is outgoing vector, incoming vector is X1. So but here two negatives are there, minus 6, minus 6. We can choose any one. So here choosing X1. So X1 is incoming vector. We have to verify outgoing vector. Outgoing vector is nothing but by using minimum ratio XP by XJ. So that is 4 by 4, 1. 6 by 2, 3. Next, 2 by 1, 2. So here minimum value is 2, minimum value is 1. So that is W1 is outgoing vector. So therefore, intersection of incoming and outgoing vector is key element. Key element, that is 4. So to make it as 1. So that implies R1 divided by 4 by using row operations. Next, remaining two elements in this column. Here, these two elements. So this one, these two elements are to make it as zeros by using row operations only. Is clear? By using row operations. In next simplex table, no need to write W1. So here W1 is artificial variable. So it is already eliminated. So no need to write artificial variable. And here intersection of incoming and outgoing vector is 4. So that is key element. So key column is first column, X1 column. And to make it as element is 1. So that is total row is divided by 4 because here 4 is there. So R1 divided by R1 by 4. So remaining two elements are to make it 0 by using row operations only. So R2 tends to R2 by R2 minus R1. So these are the row operations. R3 tends to R3 minus R1. So CB. CB is nothing but x1 coefficient in objective function 0. So W1 coefficient 1 and S1 coefficient is 0. So these are the basic variables. Here W1 is replaced by x1. So W1 is replaced by x1. Next, XB. So these are after doing row operations, we are getting this matrix. this matrix. First element is 1. So this element is 1. Remaining all are zeros. So this like this. 1, 0, 0. By using row operations. Is clear? So next. So this is the second simplex table. So next we have to find out delta J. Delta J. So that is CB into XB 0, 0, 0. All are zeros. Next CB into X1, X2 0, 3, 0. 0 into 1 by 2 0, 1 into plus 1 into 3 3 plus 0 into 3 by 2 0. So that is total 3. Cj minus Zj 0 minus 3 minus 3. Next second one. So this is 0 3 by 2 0. Total 3 by 2. 0 minus 3 by 2 is minus 3 by 2. So that is minus 3 by 2. Next mu1. First 0 into minus 1 by 4 0 plus 1 into 1 by 2 total 1 by 2 0. So 0 minus Tj minus Zj. So that is minus 1 by 2. Next here also total 0 plus 1. Here total 0. Remaining two zeros. So these all are Zj delta J values. So in these delta J values we can choose minimum most negative. So this is 0 minus 0.5. So this is minus 1.5. So most negative value, least negative value is nothing but minus 3 only. So this is the incoming vector. So we can identify outgoing vector. So that is based on minimum ratio. So minimum ratio is nothing but xp divided by xj. xb divided by xj. So here 1 by 2 divided by 1 by 2. First one 2. Next 4 by 3. So 1 point something. Next 2 by 3. So in these, so minimum value is nothing but here 3 by 2. So 3 by 2. First one 2. Next 4 by 3. Next 2 by 3. So these are the minimum ratio values. 2. So this is 1 point something. So this is 0.5 something. 0.9, 0.66. So this is the most minimum value. So this is 2. This is 1 point something. This is 0.88. So last one is least. That is minimum value. So intersection of incoming and outgoing vector. S1 is outgoing vector. So this is the key element. Key element. So the total row is multiplied by 2 by 3 because to make it as 1 key element must be 1. So therefore the total row is multiplied by 2 by 3. Next to make these two elements are above elements are zeros by using row operations. Is clear? By using row operations. So therefore S1 is outgoing vector and X2 is incoming vector. So that is CB. Next simplex table 0, 1, 0. X1 basic variables W2, X2. S2 is replaced by S1 is replaced by X2. Next. So this is the matrix after doing row operations. So this is the matrix after doing row operations. Is clear? Next. This is not new to printing mistake. 2 by 3, 2. So this is number. The next. So remaining next we have to find out delta J. So delta J values, same formula. CB X1 minus CJ. 0, 0, 0. Total 0. Second value. X2. Here also total 0. Next. Third one. 0, 2, 0. So therefore, Cj minus Z into J. Zj. So that is minus 2. Next. Cj into mu 2. 0 minus 1. So total plus 1. So here 2 plus 2. So remaining zeros. So all these delta J values, only one negative, that is lambda 1. So this is the incoming vector. Incoming vector. So we can choose outgoing vector. So we can choose outgoing vector by using minimum ratio. So minimum ratio is nothing but xb by delta lambda 1. So that is 2 by 3 divided by 3 by 1. So that is 3 by 1. So total 2. So first one 2. So next 2 by 2. So next 2 by 2 is equals to 1. Second element is 1. First element is 2. So next we are not consider negative values in minimum ratio. So here number is there. Printing mistake. This is not mu 2. Here number is there. So minus 1 by 6. This is not a minus. This is negative value. We are not consider negative values. So first element is 2. Second element is 1. Next last element is undefined. Not consider negative values in minimum ratio. So that is 2, 1, undefined. So therefore, entering variable is lambda 1. So lambda 1 is entering variable. So next, we can choose outgoing vector is nothing but outgoing vector is W2 by using minimum ratio. Here minimum ratio 2, 1, undefined. So minimum value is 2. So that is W2. So W2 is outgoing vector. Incoming vector is lambda 1. Is clear? Next, intersection of incoming and outgoing vector is key element. So to make it as 1, so divided by R2 divided by 2. So total row is divided by 2. So this element is 1. So next, to make upper element and lower element should be 0. So that is this element 0. So this element also 0. By using row operations only. 0, 0. Next, table 4. Simplex table 4. Basic variables are CB 0. Basic variables are x1, lambda 1. So this is x2. Here also printing mistake is there. X2. So this is x2. X1, lambda 1, x2. So x1, lambda 1, x2 coefficients in objective function 0, 0, 0. And next table, we can eliminate W2 also. No need to write W2. So this is the after doing row operations. This is the matrix 1 by 2, 1, 0, 0, minus 1 by 13, 1 by 6, 0, 1, 0, 0. Second row, third row. Next, we have to find out delta J values. All delta J values. So clearly we can observe all the delta J values are non-negative. That is, all delta J's are greater than or is equals to 0. So therefore, the table is optimal. So therefore, the optimal solution is x1 is equals to 1 by 3, x2 is equals to 5 by 6, lambda 1 is equals to 1. So these are the solutions of given quadratic programming problem. So that is x1 is equals to 1 by 3, x2 is equals to 5 by 6, lambda 1 is equals 0, lambda 2 0, mu1 0, mu2 0. Remaining all variables are 0. So these are the solutions. Remaining all variables s1, s2, lambda 1, lambda 2, mu1, mu2 all are zeros. So therefore, these are the solutions of given quadratic programming problem. So therefore, the maximum value of z 4 into x1 plus 6 into x2. So these are the values: minus 2 into x1 square, minus 2 into x1 x2, minus 2 into x2 square. That is total 25 by 6. So substitute x1 x2 values in this maximum of z. So total answer 25 by 6 is the answer. After we can converting QPP2 into LPP, we can follow the simplex method. So up to here, conversion. Next, we can follow the simplex method. Previous class, simplex method, big A method, two-phase method. So here we are using only big A method. Next, Beal's method. Next method, Beal's method. So this is the last method in unit 14. So in this unit 14 only, KT conditions 4 marks question. So this is KT conditions 4 marks question. Wolf method and Beal's method, long questions. Next, Beal's method. Next, Beal's method. Here also same question. Same example, previous example. Maximum of z is equals to 4x1 plus 6x2 minus 2x1 square minus 2x1 x2 minus 2x2. So subject to constants x1 plus x2 x2 less than or is equals to 2 and x1 comma x2 greater than or is equals 0. Previous example. So this is this example same previous Wolf method example.
సార్ డిఫరెన్స్ ఏంటి సార్?
ఏంటమ్మా డిఫరెన్స్ వుల్ఫ్ మెథడ్ కి బీల్స్ మెథడ్ కా?
అవును సార్.
వుల్ఫ్ మెథడ్ లో మనము ఓన్లీ సింప్లెక్స్ మెథడ్ యూజ్ చేస్తాం. ఇక్కడ చూడండి ప్రీవియస్ ఎగ్జాంపుల్ ఇక్కడ చూడండి, ఇది సింప్లెక్స్ మెథడ్ యూజ్ చేస్తాం ఇందులో, ఇది వుల్ఫ్ మెథడ్ లో. సో కానీ బీల్స్ మెథడ్ లో సింప్లెక్స్ మెథడ్ యూజ్ చేయం. డైరెక్ట్ మనకి ఓన్లీ డిఫరెన్షియేషన్ తోటి ఫస్ట్ ఆర్డర్ డెరివేటివ్ సెకండ్ ఆర్డర్ డెరివేటివ్ చూజ్ చేసుకొని ఆ సెకండ్ ఆర్డర్ ఫస్ట్ ఆర్డర్ డెరివేటివ్ తోటి డైరెక్ట్ చేసేస్తాం ఆన్సర్. సింపుల్ గా వచ్చేస్తుంది. అంతే డిఫరెన్స్ ఉంది. సింప్లెక్స్ మెథడ్ కొంచెం కాంప్లికేటెడ్
ఎగ్జామ్ లో ఇలా అంటే స్పెసిఫై చేస్తారా బీల్స్ మెథడ్ చేయాలి ఇలా
మెన్షన్ చేస్తాడమ్మా. ఎగ్జామ్ లో మెన్షన్ చేస్తారు. బీల్స్ మెథడ్ వుల్ఫ్ మెథడ్ అని మెన్షన్ చేస్తారు. కన్ఫామ్ గా మెన్షన్ చేస్తారు. ఇన్
అదే
కేస్
సార్.
మెన్షన్ చేయకుంటే బీల్స్ మెథడ్ చేస్తే బెటర్. ఎందుకంటే సింపుల్ గా వస్తుంది బీల్స్ మెథడ్ మనకి.
ఓకే ఈజీగా
ఈజీగా ఉంటుంది. ఓన్లీ డిఫరెన్షియేషన్స్ ఉంటుంది. మన సింప్లెక్స్ మెథడ్ ఇక్కడ సింప్లెక్స్ మెథడ్ కొంచెం కాంప్లికేటెడ్ ఉంటుంది వుల్ఫ్ మెథడ్ లో. ఇందులో
ఓకే సార్.
ఇవి ప్రీవియస్ ఎగ్జాంపుల్స్ ని టెక్స్ట్ బుక్ లో ఉన్న ఎగ్జాంపుల్స్ కి సొల్యూషన్స్ ఇవన్నీ.
ఓకే
సో ఇది వుల్ఫ్ మెథడ్, బీల్స్ మెథడ్. సో ఈ ఎగ్జాంపుల్ ఒకటి ప్రీవియస్ క్లాస్ ఎగ్జాంపుల్ చెప్తాను. So this is the example for. So maximum of z is equals to f is equals to 4x1 plus 6x2 minus x1 square minus 3x2 square subject to constants x1 square plus 2x2 square x1 square plus 2x2 square 3x2 square subject to constants x1 plus 2x2 less than or is equals to 4 and non-negative constants x1 comma x2 greater than or is equals to 0. Here, so we can add a slack variable. So that is non-subject to constants. So this is the subject to constants. So we can add a slack variable. Introducing a slack variable. So that is x1 plus 2x2 plus x3 is equals to 4. So this is the slack variable. And choosing x3 as the external basic variable, we have x3 is equals to x3. So here two cases. So first we can take x3 as basic variable. So next case we can take x4 as basic variable. Here only one is there. In case two or more variables are there, for example another equation is there, so we can add x4. So here two cases. So first case x3 as basic variable, next and x4, second case x4 as non-basic variable. So we can consider two cases. So but here only one is there. xp is equal x3 is equals to x3 non-basic variables. So this is the x3's basic variable and non-basic variables are x1 x2. Is clear? Non-basic variable xnb is nothing but x non-basic variables are x1 x2. That is given in question. With x1 is equals to 4, x3 is equals to 4, x3 is equals to 4 if x1 x2 is 0. Is clear? x1 x2 is equal to 0, so that is x3 is equals to 4. We can choose x3 as basic variable and remaining two variables are non-basic variables. So that is x2 and x1. Next, x1 is equals to x2 is equal to 0. We are getting x3 is equals to 4. Next, expressing basic variable coefficients function. So that is x3 is equals to 4 minus x1 minus 2x2 in this equation. In this equation, x3 is equals to x3 is equals to 4 minus x1 minus 2x2. So next, f is equals to, so that is f is nothing but given function. So this is f value. F is equals to minus x1 square minus 3x2 square plus 4x1 plus 6x2. Is clear? So this is the f and x3. The partial derivative of f with respect to non-basic variables. So at nxb is equals to 0. So differentiate x with respect, differentiate f with respect to non-basic variable. So that is x1, x2. x1, x2. Is clear? So differentiate with respect to x1.
సార్
We can choose. చెప్పండి.
ఇక్కడ ఎఫ్ మనకి 4x1 ఉంది కదా సార్, ఇక్కడ మనకి -x1 స్క్వేర్ వచ్చింది అంటే
ఇక్కడ
ఓకే. ఓకే.
నుంచి రాశారమ్మా. ఇక్కడ
ఓకే.
మైనస్
ఓకే. ఆ! ఓకే.
x1
ఓకే.
స్క్వేర్
ఎక్స్చేంజ్
మైనస్
చేశారు.
3x2 స్క్వేర్. ఫస్ట్ ఆర్డర్ రాశారు. ఏంటి సెకండ్ ఆర్డర్ నుంచి ఫస్ట్ ఆర్డర్ రాశారు.
ఓకే.
నెక్స్ట్ సో differentiate with respect to x1. F differentiation with respect to x1. So that is 2x1 plus 4 is equals to 4. Next, differentiation with respect to x2. So 6 minus 6x2 is equals to 6. So that is equals to 6. That is equals to 4. Because x1 is equal to 0, here getting 4. X2 is equal to 0, we are getting 6. That is dou f by dou x1 is equals to 4 and dou f by dou x2 is equals to 6. At x1 comma x2 is equals to 0 case. So next, here minimum of alpha h naught by alpha hk mu k naught by modulus of mu kk. So minimum of alpha 30 by alpha 32 mu 20 by mu 22. So that is equals to, so these are the formula. So this is the formula. So 4 divided by 32. The formula only. The formula అమ్మాయి ఈ ఫార్ములా నేను చెప్తాను ఒకసారి మళ్ళీ. Also minimum. So this is the formula. ఈ ఫార్ములా ఒకసారి ఎక్స్ప్లెయిన్ చేస్తాను నేను. So I can explain. So
సార్
minimum
ఒకసారి రిపీట్ చేయండి సార్ ఫార్ములా.
చేస్తానమ్మా ఒకసారి. So minimum alpha h naught by alpha h into k comma gamma k naught by gamma kk. So that is equals to minimum of 30. So 30 by alpha modulus of alpha 3 comma 2. So modulus of alpha 3 comma 2 comma gamma 2 comma 0 by modulus of gamma 2 comma 3. సో ఈ ఫార్ములా మీకు ఇందులో ఉందో ఒకసారి చూద్దాం. మీకు ఇందులో ఫార్ములా ఏం లేదమ్మా, డైరెక్ట్ ఇచ్చాడు. సో మీకు ఇచ్చిన క్వశ్చన్ లో డైరెక్ట్ డిఫరెన్షియేషన్ చేసేసి డైరెక్ట్ పాయింట్ వస్తుంది. ఆ పాయింట్ సబ్స్టిట్యూట్ చేస్తే ఆన్సర్ వస్తుంది డైరెక్ట్. మనకి 2 కేసెస్ ఉన్నాయి ఇక్కడ. So this is minimum of 4. Alpha is nothing but 3 comma 0 is nothing but 4. 4 by 6, 4 minus 6, that is minus 2. So 6 by 0 minus 6, that is equals to minimum is nothing but 1. So this is no need. Next, u1 is equals to, after differentiation, so these are the formulas. u1 is equals to 1 by t into dou f by dou x1. So that is 1 by 2, 3 minus 3, 3x2. So now xb is equals to x2 comma x3. Here two cases. So first one, in basic variable x1 comma x2 are the basic variable, non-basic variables. So we can interchange. So we can interchange the basic variables as x2 comma x3. So that is non-basic variable is only x1. So two cases. X plus a non-basic variable in terms of basic variables. Same. x2 is equals to minus x3 is equals to 4 minus x1. 2 into 1 minus mu1 by 3. That is equals to 2 minus x1 plus 2 mu1 by 3. So this is very simple. For a different reasons. మీ టెక్స్ట్ బుక్ లో ఇదేం థీమ్ ఇవ్వలేదమ్మా మీకు. సో మీ టెక్స్ట్ బుక్ లో డైరెక్ట్ సింపుల్ గా ఉంది ఇంకా సేమ్ క్వశ్చన్. సో దీస్ ఆర్ ది నెక్స్ట్ యాడింగ్ వేరియబుల్స్ x3 x4. సో 2x1 plus 2x2 plus x3 is equals to 10. x1 plus 2x2 plus x4 is equals to 10. So these are the non-negative variables. So next, so we can choose basic and non-basic variables. So that is x1 and x2 expressed in terms of non-basic variables, that is x3 and x4. So we can take x3 is equals to 0, x4 is equals to 0, x3 0, x4 0. So we are getting x1 is equals to 8 in this equation. So this is x1, x2, x1 in first equation, x2 in second equation. x1 is equals to 8 plus x1 is equals to 8, x2 is equals to 1, x3 is equals to 0, x4 is equals to 0. So in this equation, so 10 into x1. So 10 into x1 is equals to this one, 8 x3 minus 2x4 plus 25 into x2 minus 10 into x1 square minus x2 square minus 4 into x1 x2. So that is pi of x comma 3. So directly differentiate this equation with respect to x3 and x4. We are getting two equations. So this is differentiation with respect to x3. So this is differentiation with respect to x4. And at x3 is equal 0, x4 is equal 0. After differentiation, x3 is equal 0, x4 is equal 0. So that is minus 145, 299. So these are the dou z by dou x3 at x3 comma x4 is equal 0, dou z by dou x4 at x4 comma x3 is equal 0. Here, first one in negative function is a negative objective function will be decreased if x3 is increasing. If x3 is increasing, differentiation should be positive. So that is, this is the, so this is maximization of objective function. So this is totally positive. 299 is greater than 0, will be increasing the objective function. So clearly x4 should be increased from 0. So this is nothing but if x3 is increasing objective function, increasing. If x3 is increasing, objective function should be reaches to positive. So that is maximization of the objective function. So next here, so this is total positive. If increasing, this value also increasing. So that is first case. From x1, 8 plus x3 minus 2x4. x3 is equal 0. x4 can be increased to 0 at most up to the value. Otherwise, x1 will be negative. So this is nothing but in these two values, if x1 is increases, x3 also increases. Here also, dou z by dou x4 is vanish at x3 is equal 0. So that is x4 is equals to 299 by 66. So that is 4.53. So similarly, choosing x4 is x4 is maximum. So that is 4. 4 comma 299 by 66. So this is the new basic variable of x4. So similarly, x2 and x4. So two cases. First we can choose basic variables x1 and x2. So next case we can choose basic variables as x2 and x4. Here x2 and x4. So we can apply same 10 into there is no x1 as it is x1 25 into x2 minus 10 into x1. So this is x2 x4 same process. So we can differentiate with respect to x1 and x2 equating to 0. So we are getting answers. So these are the minus 35 by 2. So this is minus 15 by 2. So these are the final answers. Two cases. Basic, we can choose basic variables as first basic variables x1, x2, second basic variables x2 and x4. Or so we can choose x1 and x3 and x4 also. Like so this method is repeated next class లో ఈ మెథడ్ మళ్ళీ ఎక్స్ప్లెయిన్ చేస్తాను ఇది బీల్స్ మెథడ్ వేరే నోట్స్ లో చూసి చెప్తాను ఇదంతా
Okay,
క్లియర్ గా
sir.
ఏం లేదమ్మా ఇది
Sir.
మీకు చెప్పండి అమ్మా.
సార్ మోడల్ పేపర్ క్వశ్చన్స్ పీడిఎఫ్ నేను షేర్ చేస్తాను రేపటి క్లాస్లో ఎక్స్ప్లెయిన్ చేస్తారా సార్?
నాకు ఒకసారి పంపించండి అమ్మా. నాకు పంపిస్తే నేను అందులో రిపీటెడ్ అయిన క్వశ్చన్స్ నేను రేపు ఒకసారి చెప్పేస్తాను మీకు.
సరే సార్, అది రేపు లాస్ట్ క్లాస్ కదా సార్, ఆన్లైన్ క్లాస్.
అవును, మీకు ఏమైనా డౌట్స్ ఉంటే కూడా చెప్పండి అమ్మా. మీకు ఈ టాపిక్స్ లో డౌట్ ఉంటే చెప్పండి, నేను ఆ డౌట్ ఉన్న టాపిక్స్ మీకు స్టెప్ ఎక్స్ప్లెయిన్ చేస్తాను. ఆన్లైన్ లో ఏ పేపర్ ఏ క్వశ్చన్స్ ఎక్కువ సార్లు రిపీట్ అంటే చాలా టైమ్స్ రిపీట్ అయిన క్వశ్చన్స్ కూడా చెప్పండి, అవి నేను చెప్తాను. నేను మీకు రేపటి క్లాస్ లో చెప్తాను అది.
సరే సార్, నేను పీడిఎఫ్ సెండ్ చేస్తాను సార్ మీ నెంబర్కి.
పంపించండి అమ్మా, నేను చెప్తాను నెక్స్ట్ క్లాస్ లో చెప్తాను. ఇంకా మీకు ఏమైనా డౌట్స్ ఉన్నాయమ్మా ఇందులో? మీకు ఇంకా టాపిక్స్ ఏమున్నాయంటే
సార్ 9th చాప్టర్ లో కొంచెం డౌట్ ఉంది సార్, అది ఆ క్వశ్చన్ మోడల్ పేపర్ లో ఉంది సార్. 9th చాప్టర్ లో
టాపిక్ అమ్మా?
జాబ్ సీక్వెన్సింగ్ ప్రాబ్లమ్స్ లో ఒక ప్రాబ్లం వచ్చింది సార్ మోడల్ పేపర్ లో.
ఓకే, అది నాకు పంపించండి అమ్మా, నేను చెప్తాను. ఇంకొకటి ఏంటంటే మీకు అసైన్మెంట్ ప్రాబ్లం చెప్పలేదు అనుకుంటా. అసైన్మెంట్ ప్రాబ్లం చెప్పలేదు. అసైన్మెంట్ ప్రాబ్లం చెప్పాలి అది.
సార్ ఆ పీడిఎఫ్ కూడా ఉంది సార్ నాతో. సార్ రెండు సెండ్ చేయమంటే చేస్తాను సార్, రేపటి క్లాస్ లో కొంచెం ఎక్స్ప్లెయిన్ చేయండి సార్.
నేను చెప్తానమ్మా, అది రేపటి క్లాస్ లో చెప్తాను. అందులో ఈ అసైన్మెంట్ ప్రాబ్లమ్స్ ఒకసారి నేను ఇప్పుడు ఎక్స్ప్లెయిన్ చేస్తాను, కంప్లీట్ అయిపోతుంది.
సరే సార్, థ్యాంక్ యూ.
అసైన్మెంట్ ప్రాబ్లమ్స్ Assignment problems. Assignment is nothing but assignment problems. Chapter number, I think 6 or 7. Hungarian assignment questions or Hungarian assignment problems. So solve the following assignment problem. Is given subordinates task 1, 2, 3, 4 A, B, C, D. So we can assign each person as each subordinate or each task as one person. So this is the question. In this question, in first row, so we can identify minimum value. So minimum value is 8. So subtract each and every element in this first row. 8 minus 8, 0. Next, 26 minus 8, 18. Next, 17 minus 8, 9. Next, 11 minus 8, 3. So this is first row. Next, second row, identify smallest element in second row. So that is smallest
4.
element is 4. So that is to subtract each and every element in that row. So 9 minus 4, 13 minus 4, 9. Next, 28 minus 4,
24.
24, 0. And 22.
20.
So next,
20.
similarly,
15.
third row also. 15 is the least element. So 38 minus 15, 23. Next, 19 minus 15, 4. Next, 18 minus 15, 3. 15 minus 15, 0. So this is the third one. Next, fourth row least element is 10. So that is 19 minus 10, 9. 26 minus 10, 16. 24 minus 10, 14. 10 minus 10, 0. So this is the row reduction. So this is called row reduction matrix. So next we can apply column reduction. Column reduction is nothing but, so similarly, so we can choose column
Same.
wise least element. In first column, 0 is the least element. So 0 is the least element is nothing but that column should be same. 0 minus 0, 0. 9 minus 0, 9. 23 minus 0, 23. 9 minus 0, 9. So next, second column. So second column least element is 4 is the least element. Second column 4 is the least element. So 18 minus 4, 24 minus 4, 4 minus 4, 0, 16 minus 4. So that is
0.
here 14, 20, 0, 12.
14, 16.
Next,
12.
third column, fourth column contains zeros are there total.
Same
So
repeat.
same columns. Third column 0 is there, fourth column also 0 is there. So here also third column same, fourth column also same. So this is the column reduction. First we can row reduction. Next, apply column reduction. Next, zero assignment. So zero assignment. So this is the important one.
Yes, sir.
So first we can choose single zeros in first row. First row has single zero, no? First row single zero. So to mark the single zero, first row we can choose row scanning, row wise. So we can choose row wise first row. First row only single zero. We can mark the single zero. In case 2 or more zeros are there, leave it. It's clear. Only single zero is there. We can mark the single zero and cross out any zeros in that column. In first column, there is no zeros are there.
Yes,
There is
sir.
no zeros. So we can proceed to second row. In second row, only single zero is there. So that is mark that row. Mark that 0. So that is second 0. And to cross out any zeros in that column. So third column, there is no zeros. Only single 0 is there. Next, third one, third column. Third column, 2 zeros are, third row, 2 zeros are there. So we can leave it. Next, we can choose next, fourth column, fourth row. Fourth row, only single 0 is there. So we can mark that 0. We can
Yes,
mark
sir.
that 0. Cross out any zeros in that column. That is
Second.
fourth column, 1 0 is there. So
So
cross
second.
out that 0. Is clear? Cross out that 0.
Okay.
First, row reduction. Next, column reduction. Next, zero assignment. So zero assignment is nothing but this is the important one. So we can choose row wise. So first row is only single zero, mark that row. Next. So second row only single zero, mark that row. Next, third row has two zeros here and here. So leave it. We can go to next row. And fourth row only single zero is there. So mark that zero. Cross out any zeros in that column. So here 1 0 is there. You can cross that zero. Next. So row scanning is completed. Next column wise. So first column no zeros are there. Second column zero is there. So this is the
Yes.
zero. Mark that zero. Cross out zeros in that row. We can choose column wise. That is nothing but we can cross out zeros in row. We can choose row wise. We can cross out zeros in that column. So there is no zeros. Next, third row has no zeros. Fourth column also no zeros. So these are the assignment. A is assigned to first job. B is assigned to third job. C is assigned to second job. And D is assigned to fourth job.
Fourth job.
So final answer is nothing but, so we can identify in original matrix. So that is, so these are the assignments. 0 here. These are the assignments. So answer
8.
is nothing but 8. So this is the marked zeros. So here marked zeros here, 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 here. The original values of marked zeros. So here 8 is there.
Yes, sir.
8 plus. And here C second one.
4.
C second one.
19.
19.
19.
So 19. Next, here B third one. So this one.
4.
B third one plus 4. Next, last one plus 10.
10.
So this is the answer.
10.
Okay.
So this is the final answer.
Yes.
So these are the assignment problems. So here we can write assignment also. So A is assigned to 1, B is assigned to 3. So that is marked zeros.
Yes,
And
sir.
C is assigned to 2, D is assigned to 4.
4.
So the total optimum, the total assignment cost is nothing but 4 plus 8 plus 19 plus 10. So that is 41. This is the answer. So these are the assignment problems.
Okay, sir.
సార్ నోట్స్ ఫార్వర్డ్ చేయండి సార్.
We will continue on next class.
సార్ నోట్స్ ఫార్వర్డ్ చేయండి సార్.
నోట్స్ ఫార్వర్డ్ చేస్తానమ్మా. ఒకరు
Okay,
చేస్తాను,
sir.
మీకు పంపించేస్తారు.
ఓకే సార్.
ఓకే, నెక్స్ట్ క్లాస్ లో చూద్దాం ఇంకా.
Okay, sir.
ఓకే సార్, థ్యాంక్ యూ.